All right, this lesson is on the binomial theorem, but before we get started with that, I wanted to talk a little bit about combinations and make sure that you're familiar with some of the common combinations that are out there. And so what we did in class is we went through and looked and kind of tried to organize it where we said, okay, what are the combinations of, and we just went through kind of all the possibilities. 0, choose 0. Or what if there's 1 and we choose 0? Or 1 and choose 1. Or maybe there's 2 and we choose 0, or 2 and we choose 1, or 2 and we choose 2. And then we went to 3s. What about 3 choose 0, or 3 choose 1, or 3 choose 2, or 3 choose 3? And we looked at all of these possibilities, and it creates kind of this pyramid thing. And so we split up the work and figured it out, and we got the 0 choose 0 to be a 1. And then 1 choose 0 happened to be 1, and so did 1 choose 1. And then we'd have a 1, and we got 2 and 1, and then it was 1 and 3 and 3 and 1. And we really went farther than that. I'm just out of room. You could keep going with that. But what this is looking at these combinations. This creates what we call Pascal's triangle. Blaise Pascal was a mathematician. He did a lot with probability. He actually wrote a book on gambling that was a hot commodity at the time. And he used these combinations all the time. He didn't have a calculator to do it, so it was kind of important for him to find out what some of these common ones are. The ones that I want you to realize probably are, if you look at this, anytime you're choosing 0 here, notice that you're always getting 1. Okay, if you're choosing 1, then you get the number itself. A 3 choose 1 is 3. A 2 choose 1 is 2. 7 choose 1 is 7. Okay, so instead of entering those in your calculator, you should start recognizing, I'm not going to type in 7 choose 1. I know it's just a 7. All right, so with that, this Pascal's triangle, you know, we did these combinations, but it is full of all kinds of cool patterns. And the only one I'm going to really focus on is how do you build it without having to do all the combinations. And so if you go through and you did the 4th row, this is called row 0, row 1, row 2, row 3. And so if we were to go through and do the 4th row, what do you suppose the first number would be? Well, yeah, it'd be a 1. Okay, and then here's what's kind of cool. To find the next numbers, well, it would be a 4 choose 1, so I know it would be a 4. But this number is always the sum of the two numbers above it. So if you look here, this 1 and this 2 gets you a 3. Or this 1 and this 1 gets you a 2. And here my 1 and my 3 got me a 4. So what do you suppose I need to put in this spot? Well, it should be a 6. And then this should be a 4. And then this would be a 1 again. And it is repetitive. It goes up and then it comes back down, and it's all very symmetrical. You should build in your notes like at least to maybe the 6th row of Pascal's triangle. I didn't write that there. It's Pascal's triangle is what that's called. I would pause the video, kind of jot that down. You need to be familiar with how to build that. All right, so then let's start with our binomial theorem. We started off and looked at, okay, first of all, a binomial. Remember that that's a polynomial, but it only has 2 terms. And what we're looking at is taking these to a power. And so we did a couple of these together. Like if we have a plus b and we're going to square it, basically you're just going to FOIL those together. All right, well, that's great. We're going to, but ideally, a lot of you are using the shortcut where you square the first term, multiply the 2 and then double it, and then square the last term. And there's your trinomial that you get. All right, if you do the cube, basically what you have to do is you have to take this one and you have to take it times a plus b one more time. And so then you would have to take this a and you would distribute it, take this b and distribute it. You'd end up with 6 terms there. Hopefully some like terms that would condense together, and then you'd have your a plus b cubed. All right, that wasn't too bad. But consider when you get clear down here and you've got an a plus b to the 6th, and these are just getting longer and longer and longer as they go. All right, well, it would be nice if there was a shortcut, and so that's probably why we're talking about it. We're going to use what we call the binomial theorem. And it actually goes back to that Pascal's triangle. Notice this is squared right here. Notice also that the coefficients are 1, 2, and 1. And that happens to be the second row of Pascal's triangle. And if you were to multiply this one out, the coefficients would go 1, 3, 3, 1. And this one, if you multiplied it out, without having to mess with all the FOIL and the multiplying polynomials together, you don't have any of that, you already know that you're going to end up with a 1, a 4, a 6, a 4, and a 1, because that's the fourth row of Pascal's triangle. All right, that's awesome to get the coefficients, but we also have a bunch of variables in there. So what you have to recognize then is what's happening, and you don't notice it as much on this one, but if you look in your textbook, you'll see they do several of these. You can see it better. But what happens is they take this first term to its highest power. So my first one was a squared. So in this case, it's going to be a to the third. And then the first term has this second letter, b, and it's not there at all. Well, that's because it's actually b to the 0 at that stage. Plus. And then what happens is this power on my a goes down, so now up here it's only to the first, and the power on the b starts working its way up, and so it's to the first. So then this would end up being a 3, a works its way down, so now it's squared, b is going to work its way up, now it's to the first. Plus, keep it going, next coefficient is a 3 from Pascal's triangle, a works its way down, so it'll be a to the first, b works its way up, it'll be squared. Plus, last one is going to be a 1, a is going to be to the 0, b is going to be to the third. And we would clean this up. I really wouldn't put these 1s here usually, and certainly not a to the 0, that would just go away. I wouldn't write a 1 for my exponents, I would just leave it. And so that's the pattern, though, that we use. Okay, so let's try this one real quick. It would be, well, actually, you know what I'm going to do? I'm going to go to the next slide for us to figure out. Okay, this is what it looks like in your textbook. Basically, this is explaining the pattern. It may not mean anything to you. This might be even uglier to try to track. Let's just do a few so we can kind of get the hang of it. Okay, so the one that I have here is actually an a plus 3 to the 5th. This is a little bit different because it has a 3 in it instead of a b. And so what that means is we're going to start having some other numbers involved. All right, so let's look at what this first part is right here. And you have to kind of recognize these are all the terms right here. Notice there's no addition or subtraction in between those. Those are all being multiplied. And so this right here, this combination, is really that Pascal's triangle number. Because remember, the triangle came from finding all the different combinations. Okay, so if I'm going to go to the 5th power, then I'm going to go to the 5th row of Pascal's triangle. Okay, go back and look at your Pascal's triangle. What are your coefficients on that? You should have a 1, and then a 5, and then a 10, and another 10, and then a 5, and then a 1. Okay, so if those are the coefficients from, or the numbers from Pascal's triangle, those are going to be my coefficients that I use. So here I go. I'm going to start off with a 1. And then I take my first term, which is an a, and I'm going to take it to its highest power. And then I'm going to take it times this 3, and it's going to be to the lowest power, which is a 0. Plus. So I just did this part right here. Now I go to the next one. And I do that combination, but it's really just the 5 from Pascal's triangle. And a is going to work its way down. The b, or in this case the 3, is going to work its way up. Plus, just finish that one. Do it again. 10. A works its way down, and the 3 works its way up. Plus, another 10. A to the 2nd, 3 to the 3rd, plus 5. A to the 1st, 3 to the 4th. Last one, 1, a is going to be to the 0, and the b, or in this case the 3, is going to be to the 5th. And we've got it. We're done. Well, we're not really done. Now we need to go clean it up. All right, so each one of these represents a term in this polynomial. So this first one, you have to work with your numbers first because they're going to be your coefficients. So this 3 to the 0, that's just 1, times that coefficient of 1 is just 1, and that all just cleans up to an a to the 5th. Nice and easy. Plus. Okay, here I have a 5, but I also have this 3 to the 1st, which is 3, and 3 times 5 is 15, a to the 4th. Plus. I've got a 10, and I've got a 3 squared. That's 9 times 10, so that's 90, a to the 3rd. Plus, I've got a 10 times 3 cubed, that's 270, a squared. Plus, and then I have a 5 times a 3 to the 4th power, so that ends up being 405, a. Plus, and then my last thing, I got that a to the 0, got that 1. All that really is there is that 3 to the 5th power, and that's 243. And so that is my final condensed answer, without having to do FOIL or multiplying anything out even one time. Now, if you haven't had to do the FOIL, if you were gone and didn't have to do the a plus b to the 6th power, you maybe don't fully appreciate this, but if you're having to multiply these out numerous times with these high powers, this is an awesome, awesome alternative to doing that. Okay, now, before we move on to the next one, there's a couple things that I want you to notice, some patterns that are important in this. Okay, one of the things is that these exponents, if you look through that, as one is going up and the other one's going down, they still always keep a sum of whatever this degree is right here. We're going to come back to that concept here in a little bit, that those always add up to that degree. All right, the other thing I want you to recognize is that those Pascal numbers show up at this first stage, but they don't necessarily show up in your final answer. By then you've multiplied those all out. Okay, let's try another one. This one's a little different in many ways. It's got a 2 on that leading term, so that's a 2x. You've got subtraction, and your last term, your b value over there, is actually has a power on it on itself. Okay, this has got several things going on. I went ahead and just only took it to the 3rd power, so that way we don't have it forever long. But let's look at what happens on this one. So you're going to start off, and you need the 3rd row of Pascal's triangle. So the 3rd row is 1, 3, 3, 1. All right, so let's start off. First coefficient then is going to be a 1. I'm going to take that 2x, and it's going to be to the highest power, and then I'm going to take a negative y squared to the lowest power. It's really, really important that you put these in parentheses like that and really make it obvious this is its own term. If you don't put those parentheses, it looks like you've got a minus sign in the middle of that because you got that negative y squared, and that'll start to look confusing for you as you progress. Plus. Next term is going to be a 3, and then you have your 2x in parentheses. It works its way down, so it's squared. The negative y squared is going to work its way up, so it's to the 1st. Plus 3, 2x to the 1st, and a negative y squared to the 2nd. Plus 1, oh, I'm going to totally run out of room here. 2x is going to be to the 0, and my negative y squared, I'm going to have to write it down here, negative y squared to the 3rd. Okay, so here we go. Let's clean it up. So on this first one, the only number I have to deal with is this 2, and that's a 2 cubed, so that's an 8. My x is going to be cubed, and my whole y business is all to the 0 power. Remember, that's just 1, so that term won't even be there. Okay, so the next one, I'm going to have a plus, and then I've got a 3, and I've got this 2 squared, so that's going to be 3 times 4, so that's 12, x squared, and then I have a negative y squared to the 1st. Don't write it like this. Don't do that business, because now that looks like subtraction, and these are all being multiplied. So really what you do is, since it's going to be negative, that actually goes out in front like a -1, and my 12 is actually going to be a -12. So that'll be a minus 12x squared y squared. Plus, I got my 3 times my 2, so that's going to be a 6. And then my x, and we always put our variables in alphabetical order, so our x's will come before our y's. Now on this one, it's a -y squared, but it's squared, and if it's squared, that negative will go away, and I'll end up with just a y to the power to a power you should be multiplying, so it'll be to the 4th. Plus, last term, I've got my 1, I've got my 2 to the 0, that's 1. The x is going to drop off because it's to the 0, and all I have is this -y squared cubed. Oh, that's cubed, so let me go back and erase. That's going to be a minus. And then it's going to end up a y to the 6th power. You multiply those. Okay, so that's it right there. Got it. One of the things I want you to notice here is that sign flip-flops, positive, negative, positive, negative, positive, negative. Okay, that's going to happen anytime you have a subtraction sign here, because what happens is that negative gets raised to an even power to an odd power, even power, odd power, and so that'll always alternate like that for you. All right, so you have several of these on your assignment where you have to expand that all out. It's a little bit lengthy, but way, way, way better than having to multiply it out like you did in Algebra 1. Okay, so we have one more thing, a little bit of time. And so I'm not going to be able to ask you to do 10 of these on the test. So what I'm going to do is I'm going to ask you just for parts of them. So instead of doing a big, long one, look at what power I've given you here, to the 10th power. All right, I'm just going to ask for like one of the terms out of the whole expansion there. Okay, so if I'm going to ask for just one of the terms, let's think through how that's going to happen. All right, so this first one says, find the coefficient of the x to the 7th term in 2 minus 3x to the 10th. Okay, so here we go. I'm really going to do this right here. I'm not going to even worry about the 10th row of Pascal's triangle. I just know that it came from doing a combination, so I'm just going to do the combination rather than worrying about Pascal's triangle. And since it's raised to the 10th power, I know it's going to be a combination of 10, choose, and I don't really know what it's choosing because I don't know really where this is going to fall in the whole expansion. So I'm going to leave it a question mark for right now. Okay, times, you take your first term to, well, you start with the highest power, but I'm not at the beginning. I'm at the x to the 7th term, so I'm just going to put a question mark, and I'm going to do the same thing for my -3x and put it to a question mark. Okay, so we have to figure out these 3 question marks. Well, one of them's going to be handed to you because they're telling you right here you want the x to the 7th, so this right here better be a 7. So we know what that is. X is going to have to be to the 7th. And remember what I told you about these 2 powers? And you probably should write this in your notes. Let me clean this up. Get rid of that. And I'm going to get rid of that because I know what that's going to be. Do you know what that's going to be? If this is going to be a 7 power right here, that these, and you should jot this down, these have to have a sum of whatever your degree is. And on this example, they have a sum of 10. So if this one's going to be a 7, this power is going to have to be a 3. Okay, the other thing I want you to notice, and this is up above in the notes part here, look at each one of these terms. And let's see if we can figure out where is, I'm trying to look for this right here in my problem. I don't know what it's 10 choose something. Where else do you see that number? Or over here, where else do you see the 1? Where else do you see the 2? Well, it's always that power on that last number that you have out there. So in this case, that's my 7. So these have to match. Okay, so instead of having a question mark, I now have a 7 there. All right, so then what I do is I go to my calculator, and I'm just going to type in my 10, choose 7. So 10 math, choose the 7. And then I'm going to take that times, because we're multiplying everything in here. I'm going to take that times 2 cubed, right? But you know that's 8. 2 cubed is 8. All right, and then I'm going to take that times a negative 3 to the 7th. Now be careful, if I'm going to take a negative number to the 7th, it's going to be negative. You have to use parentheses. I really don't worry about it. I just know in my mind it's going to be negative. I just do a 3 to the 7th and attach the negative on it. All right, so here we go. This is what you should have gotten. Negative 2099520. That is your coefficient. That's this number in the midst of this whole problem. That's just one of these coefficients that falls in here. So could you imagine what this would have looked like if we had expanded this all out, if that was one of your coefficients? All right, it's going to get a little crazy. That's why I like it. I will always probably ask you something that's a very high power, because I don't want you just to go do the whole thing to find just one term. I want you to use kind of just the shortcut of finding one term in the midst of it. Okay, one more example of this. This one is a little bit different because it has two variables. It has an x and a y. No big deal. It'll work out fine. So here's how you should set it up. It's combinations of, this time it's a degree 9, so it's 9, choose something. And then my 2x is going to be to some power, and my 5y is going to be to some power. And I have to fill in the rest. Well, this right here is my giveaway. I want my, well, they actually tell me the x and the y. The x should be to the 6th and the y should be to the 3rd. What do you notice those two exponents do? Okay, they should have a sum of 9 because that's my degree, and they do. I didn't even have to figure one out because the kind of the type of thing where they give you both. And then remember that this 3 here has to match down here, so it's a 9, choose 3. So then what you do is you type in your calculator and you're multiplying in here, okay? You're going to do 9, choose 3, and then you're going to take that times 2 to the 6th, and you're going to take that times 5 to the 3rd. And you can do it all in one shot in your calculator if you want, but I ended up with 672,000 is the coefficient on that term. All right, so that's those are kind of quick and easy problems. You have a few of those towards the end of your assignment. All right, hope this helps. Good luck.